Welcome to Executive Education in Sustainable Fashion. Today we're talking to Dr. Amanda Parks about the future of sustainability and in particular wearable technology.
Hello and very welcome to this session of our executive program in sustainable fashion. Today we're sitting down with Dr. Amanda Parks, who is the Chief Innovation Officer at Future Tech Lab. Very welcome, Amanda.
Thank you for having me.
Our pleasure. So let me start off a little bit. You're not really from a fashion background. I mean, you started at MIT. What really brought you to this point you're now at Future Tech Lab and all the work you've done so far?
Yeah, so I really started from the traditional tech industry. First was at Stanford, did a mechanical engineering degree, and then was at MIT doing a PhD joint between computer science, material science, and interaction design. So that's deep in tech. But what really brought me into it was, first of all, this focus on technologies for the body. So what you might think of as wearables, I was working on research in that space, but also looking at the fusion with soft materials, textiles, so different kinds of soft robotics. So things that involve materiality that's close to the body and close to fashion. And so that just kind of merged. And, when I got to New York, one of the ways I actually made money was to do mechanical and structural design for couture. That stuff is complicated engineering. So, 11 years at Stanford and MIT prepared me for that. But so, I definitely came in backwards through the wearables, electronics, and mechanical engineering side.
So wearables to technology and materials, etc.
Exactly.
Now, you joined or was a part of starting up the Future Tech Lab, and that was quite recent, right? You did that
it's about a year and a half ago now. Joined in the summer a year ago. And so the idea was to launch a company that really had a whole new model that would kind of move the industry forward from various angles. So the things that we saw were missing. So investment into not just brands, but into like real enabling technologies like materials, like process technologies, are the things that move production forwards from the back end, as well as have an agency and an experimental product lab where we could actually start to make products that we really think should showcase what it should be like in the future, as well as consult with both tech companies, fashion companies, and try to create a bridge between the worlds.
Right. So we're going to get into some of the projects you've been working with, and they're fascinating. But talking about Future Tech Lab, so there's a multi-purpose behind this organization, right? You're an investor, number one?
Yes, we have an investment fund, and our focus so far has been mostly on creating a new sustainable material culture.
Right.
So we invest in, startups that are doing things like reclaimed textiles, like Evernew, doing reclaimed cotton work, or orange fiber, which is like making a silky fiber from orange peels. Also biofabrication, so things like bolt threads, which you probably heard of. And my Miko Works, making mycelium leather, right, from the root structure of mushrooms. So, this range from things that seem sort of natural, taking on, restructuring how, natural materials, but all the way up through very, very high-tech biotech solutions.
So you invest in these companies.
Yeah.
Do you also, as they move forward, do you provide them with support too, or
our role that we take as an investor is really strategic. And with a lot of these companies, as you can imagine, if they're coming from deep science or deep tech, they don't have a lot of connections to the fashion industry.
Right.
And it's very hard to penetrate, actually, for an outsider. And it also kind of, scientists are very scared of it. It's quite funny. So creating those bridges in terms of introductions, but also focusing on what are the kinds of products that they should be making? Like, what is right for the industry? What does the industry need? And so to really have a back and forth conversation, we can provide that intermediary.
This is very interesting because if you look at fashion industry from an historical perspective, most of the innovation has really been at North Carolina State University or some institution like that who has worked with different fibers, fiber blends, etc. Now we're moving into culture where other technologies becomes important and etc. What do you feel about the current research and how is the connection to the industry? Do you feel this is an industry-led evolution or is this a pure scientific-led evolution of the industry?
So that's a really insightful question because one of the things that I was most struck at when I was enter the fashion industry coming from tech was how the fashion industry doesn't own the means of its own production and its own future. And what I mean by that is that, for tech companies like Google or Apple, they will absolutely have research going on internally that's looking 5-10 years out, producing what they need, the chips, the software, everything, right? So they're leading their own industry forward. But for fashion, they're not, these big companies don't have internal research labs where they're working on fiber science and textiles. And there's this very strange divide between the highest levels of research at NC State or MIT and then what is actually ending up with fashion companies. A lot of that high fiber science work is going into military technologies, et cetera, safety gear. But there's the translation of how that turns into, commercial scalable products for the everyday seemed so missing to me and such an opportunity as well. So I think that, as fashion and tech worlds are starting to kind of speak to each other and be a little more friendly, I think the fashion companies are realizing that this is something that could be part of their business model, not just because it's necessary for them, but also because it's another way to make money, like this idea that they could own their own IP around textiles and innovation in that way.
So I assume you talk to a lot of scientists and a lot of people with great ideas, etc.
Yes.
So would you say the first thing you do is vet if their idea really have a commercial application at all, or do you encourage people, if they have an interesting idea, to pursue it and see what it takes you, etc.?
Yeah, I mean, it's a mixture. So one of the parts of my job is to basically go around the world and find the best companies and the best research, whether it be in universities or different kinds of industrial labs, that could actually have some kind of impact. And, a lot of these scientists are not thinking necessarily about the commercialization, and they shouldn't be. That's not really their role. They need to get it to a prototype state. And then the question becomes, it's not whether or not it's a good idea, then it's sort of an analysis of how can you build a business model around this to make it scalable and make it commercial. And, I like to think of it, to talk about it more in the way that we think of sort of biotech or maybe developing a new drug, right? You have to put a lot of research into the beginning to get it to a state where you can manufacture it at scale. So it will be expensive at the beginning. But for most of these materials and technologies, that's not a limiting factor. It doesn't have to stay expensive. So right now in the industry, we're at this point where, yes, these new biofabricated textiles are expensive only because we haven't sort of paid off the initial investment into the technology, into the production.
So let's shift over a little bit to sustainability. For someone with as you are working with material technology, what does sustainability mean to you in your world?
Right. So my interest in sustainability came from kind of being at MIT and seeing the massive amounts of tech trash, which is everywhere. I mean, there's probably 1,000 computers in the for every person in every building, right? And you just see massive amounts of waste, and it's really kind of it affects you psychologically. And I'm not someone who loves gadgets and loves this kind of culture of planned obsolescence for tech gadgets. So I started thinking about it more from this: why aren't we reusing the components of things? Just from this, someone who builds products mechanically and technically. That was my interest in just sort of the material product development and manufacturing cycle that we live in. It's very, very broken, and it's inheriting things from the Industrial Revolution that should just be gone by now. And so this idea of thinking about new materiality, like the way that we can program materials for when to know when they can dissolve, and this sort of material appropriateness. So if something needs to last forever, we build it of a material that should last forever. But if something needs to be disposable, it should be of something that will naturally decompose, which is why plastic is really just a huge design failure. It's supposed to be disposable in most situations. It's the material that lasts the longest in the world.
So, Amanda, I want to talk to you a little bit about your work you do at Future Tech Lab, too. I know I have a lot of interesting projects going on there, and I kind of has been following some of these projects myself and as they have evolved. But I want to kind of talk about a few of these things. You have a project with a company called Evernew, correctly pronounced, right?
Yes.
That recycles cotton. Tell me a little bit what that technology is and the potential for that technology as it evolves into scalability, etc.
Yeah, Evernew is a really fantastic startup. They're kind of a model for what I think of a startup should be in this space, because their founding team has somebody that's from the fashion industry, has produced collections, and has a long history working in manufacturing, and then a high-level fiber science chemist at their core. So this combination allows them to really make a huge difference in both the science and the scale-up. And basically, they have a technology that, first of all, can separate materials. So they take post-consumer garments and then separate them down to their composite materials, cotton, polyester, et cetera. And then they're focused on taking the cotton, and they can transform that into a liquid, which can then be extruded into pure new cotton. And this is really important. First of all, because it means that the cotton retains more of its initial properties of strength and softness, et cetera. But it also means that this liquid can be combined with all new kinds of materials to make blends that we've never seen before. So they're taking something that's a waste and turning it in. They're really kind of upgrading the potential functionality and creating all new combinations of fabrics.
But does that technique allow you to blend maybe fibers that commonly are not supposed to be blended? Does it provide additional advantages in spinning of yarns, etc.?
Yeah, and they're still at kind of the early stages of this. I mean, right now they're doing things like making different kinds of denim, t-shirt, like the most basic forms of cotton, but they really haven't even tapped into what they could explore.
Right.
Yeah.
When they recycle cotton, let me ask too, because I have read that the problem with recycling cotton many times is we use a lot of spandex. Or, how are they able to really sort out the spandex out?
Yes, and that's that's under development. But the short answer is yes, it's not perfect yet in any way, and there are limitations on the chemistries, et cetera. But being able to separate the materials is a huge part of that process.
Right.
Yeah.
Exactly. I want to bring the discussion over to another project that is called Bold Threads, and probably one of the more interesting fields in material science, where you actually use bioengineering to create material, give birth to material. Can you tell us a little bit about Bold Threads and what it is, and what the technology is behind, and what the promises are that this technology shows?
So Bold Threads is using the process of biofabrication, which means that what you're taking the DNA from one organism. So they make lab-grown spider silk. They take the part of the DNA from the spider that allows it to create silk. So it's like slicing the DNA, and then they transform that into a yeast cell, into a microorganism, and breed that yeast cell. And what that does is it allows the yeast cell. So if you think of how yeast cells, like if you're brewing beer, you have the yeast, and as it metabolizes, it creates beer, and that's the byproduct. This is like yeast that instead of making beer, makes silk protein, liquid silk protein. So literally their factory looks like a brew house. It's these giant brewing containers. So they're making this liquid, and then they can extrude it. So this is a really promising part of the new technologies around sustainable textiles, because we can basically not use animals. Not that people are really that worried about harming spiders, but it's more about really, you can do it for all different kinds of animals, but also you have much greater control. You can control, we know much more about microorganisms. We can control what you feed them, how they grow. You can grow it anywhere. The labs can be anywhere. So you're industrializing that biological process.
So not being an expert in this whatsoever, but does that actually mean that one day we will be able to grow wool for ourselves too?
Yes. Yeah, potentially. I mean, every DNA is obviously, and the metabolic process of cells is very complicated. So I couldn't tell you exactly where the limitations are, but basically the cells basically manifest some kind of gene in order to grow different materials. So like the way that your fingernails make, the collagen, and so there's ways to extract those pieces of DNA. So absolutely. I mean, this is also used in growing meat, right? So so you take stem cells and you can grow meat from it. So that's kind of that's the hardest level. The higher level the organism, the harder it is to do biologically.
Is this, I mean, this is just a totally fascinating science, but do you find it hard to convey those messages when people...
Yeah, I mean, people first of all get worried that, like, if you talk about bacteria, I talk about yeast because people are more comfortable with it, is in the kitchen, but really it's a form of bacteria, microbe, and people go, oh, is my thing made of bacteria? Is it going to make me sick? there's this inverse relation. Like, we have tons of good bacteria.
Yeah.
I'm not going to get fully into that.
Right.
But I think the other thing is that the whole notion of GMO, genetically modified organisms, which is what these are, is a very controversial topic because of how it's come into the culture through Monsanto, et cetera.
Right.
But like with anything in science or tech, there's a good way to use a technology and a bad way, and this is a very positive way that needs to be very controlled and et cetera. But that's one of the other things is that people get when they realize that you're talking about genetic modification, that it's it becomes scary.
Yeah.
But also, I think one other area in this field that's really promising is the idea of actually being able to grow dye. So biofabricated natural dyes. So imagine going around the world and picking like the natural color from everything and finding the part of the plant that makes the rose pink, that particular pink color, splicing that DNA, putting it in a microorganism, and then grow that as a dye. And you can, basically there are certain companies, Peely and Colorifics, both in Europe, who are doing this, and they're basically sampling the world as a color library. And it's much better. It's not synthetic dye. It's real natural dye, but it doesn't use the resources of land, sun, water. You're not growing excess plant. I mean, you're literally just growing the color and not the whole plant. So that is, I mean, and that has imagine how that would change the dyeing industry, which is so toxic.
Yeah, totally. Dramatic change.
Yeah.
How far away is that? 5, 10, 15?
Yeah, no. I think, they're very far along in blue.
Yeah.
Somehow that's been like easier. They're making a whole color library, but they're doing like sample rounds of production.
Right.
It's also one of those things where what people need to realize that there's a complicated mixture of combinations where they just have to test it all biologically.
Yeah.
What organism should they put it in? Where should they put it? What should they feed it? How long do they grow? I mean, it's a never-ending testing cycle, so it'll just continuously be getting better.
Right.
But once they have something, you can literally just put it in a bioreactor and grow it. So it's it's getting the root organism to its perfect state.
Fantastic. Let's talk a little bit about an area you started in, which is wearable tech.
Yeah.
That both you and I know, it flew up on the radar in tremendous speed, and everybody was talking about wearable tech, and then it just disappeared.
Yeah.
What's happening with wearable tech?
Yeah. I think it's interesting. I sort of predicted that this was going to happen, and the reason, I was happy that something that I've been researching on for a while was finally kind of coming into the mainstream, but I saw all the investment money going into one very narrow channel, which is the sort of Fitbit sports device, without spreading across what's really needed to make the future of wearables. And this is what I think is coming. So what we've seen is this rise of the Fitbit, it's like wrist, ear, eye, right? Very limited to things that we can make with existing forms of hardware technology. So I'm talking about physical electronics. And it hasn't fully blended seamlessly with textiles and become soft. And part of that reason is that literally the chips, the products, the fibers don't exist to make those circuits. So each company reached a place where they couldn't make it softer, they couldn't make it smaller, right? And so we have to go back to the enabling technology, the fiber development, the nanotech, right? And this is where we're at. So they're still moving along. It's just a lot of that is taking longer, and it's a lot more secret.
So
it's not consumer.
It's a next step.
It's not. The stuff that is being developed now is not consumer facing. It's like the chips behind this and the fibers behind that. So things like, well, we need to make fiber batteries, like a fiber that is both a solar collector and a battery, transistors, replacing every component. I call it rematerializing circuitry into soft form. So every fiber will have a functionality like it would in a circuit. And so that's where we're at. So there's not a lot of action on the consumer and public facing front, but we will start seeing, when wearables will rise again is when we can do a real seamless integration into clothing, and in a way that it becomes not gadgety and things you have to remove the battery and this and that, but that you just wear it like you'd wear any other garment. You don't think about it. Like spandex is a technology. It just doesn't happen to be active, meaning it's not powered. But if you have a fiber that is collecting energy from the sun and storing that energy and powering something in the fiber, that's a passive, self-contained system. So we no longer have to think about it in this, is it an electronic or not? And that's when we'll see a real kind of next gen.
Yeah.
You know, you'll see the beginning of that in things like Levi's Project Jacquard, right, which has embedded conductive threads as a control structure, capacitive sensing. That's the tip of the iceberg as we move forward, but this is going to take longer.
Yeah.
So, 5-10 years to get to real products
Right.
that are,
I know that the battery and the powering of these things
Huge.
is a big issue, and working in fashion, I've been at factories where they proudly show me the jacket that heats up itself, but
Yeah.
the battery is clumsy, the webbing of the wires is clumsy, etc.
Yes.
Will the day come when we resolve these battery issues and we actually can take a jacket on and put it on 68 degrees and walk outside
Yes.
and feel comfortable? You feel that is...
Absolutely, and that's one of my kind of pet things is to solve the energy problem, because
Yeah.
not like a fiber battery to me is the holy grail of this space, and it's out there in research in various states, and we're getting involved. But the point is that this will power any kind of functionality, so it'll be universal, as well as it can power other things around the environment. Or it'll be like you can just be a mobile power source. It could maybe take the energy from your body and put it into other things. So that to me is fully transformative in the way that we think about the IoT and all kinds of interactive technologies.
It's equally fascinating.
Yeah.
So I want to ask you too, because there's a lot of talk right now about artificial intelligence. And what is the connection between material technology and artificial connection? Is there a connection? And if so, what is the connection between the two?
I think the most important connection, and this is sort of, and where it's breaching the fashion industry at the most basic level, is how we think about what we're producing, when, why, and where. So this data and information platform. So if we, one of the biggest issues with fashion and production is that we just make too much, and we don't know what we should be making for what markets, and that's why there's, lots of stuff that's not sold and not worn and everything. And so using artificial intelligence in predictive mechanisms, in understanding data algorithms to understand data around things is a really important place to kind of put that into production. And then also just thinking about the manufacturing technologies, factories, automation. I know people get very scared about the robots are taking our jobs, but I don't subscribe to that Luddite fallacy.
Yeah.
This is just a natural progression, and the development of automation in factories doesn't just remove jobs. It makes different jobs. We need an education plan to shift people.
Yeah.
It makes better jobs and safer jobs. Right. It shifts where they could be.
And eliminates the mundane task.
Yeah, exactly. So there's a lot of it could open up people to actually have more creativity and have better jobs. But it's a complicated question that's not just technological. It's also sociopolitical.
Yeah. If you look at a landscape that we are in the midst of now with fashion and technology, what do you think are the major change makers? What really needs to happen in order for the industry to connect with technology in the right way? Is it just the scalability, or is it the interest from the industry to themselves invest into technology and being knowledgeable about technology?
Yeah.
Or what is there something missing right now, you feel, in the link between the fashion industry and technology?
It's a combination of things. I think that the big brands because they have so much power in terms of money and production capabilities and outreach, I think getting them more involved in the research side, really owning the means of their own production, which I mentioned before, understanding how textiles get developed, and maybe they're not doing things internally, but really partnering deeply from the very beginning of their whole material supply chain and their production technologies, and being an active player in that. So it's not to say that fashion companies need to become tech companies, but there needs to be crossover knowledge, and they need to be welcoming it, as opposed to a lot of the companies, because of the craft heritage and stuff, it's been shunned. And so, I talk a lot about how technology can actually save couture, because you can free up the people who need to be creative and still retain craft and everything like that. But you can use the technology for some of the more monotonous parts, and this kind of this collaboration of like what we call digital craft is a really where things can come together in beautiful ways. It's working really well in architecture, but architects have always been more connected to the technology industry. And so I think that it's the digital craft piece that I think will be very interesting. And then the other thing is really about investment. And where the money goes, and especially for new technologies. And there's been, the Silicon Valley model of investment is totally broken, and people are starting to recognize it. It's just like a gambling thing where we're making technologies that are not world-changing. They're kind of gimmicky. And so, especially for these base, things like the enabling fiber science kinds of things, we need to change where the money is going, and people are starting to kind of wake up to that, because a lot of the startups in the space had a very hard time getting some initial money because it wasn't coming from the fashion industry. It was sort of on the outskirts of biotech. It wasn't an app. Like, they were in this lost valley of funding.
But that, I assume, is a very important function of your company, too,
Absolutely.
to fund people that really does, and the ROI is very far ahead in the future, and they need this in order to bring it to the next step. So
a shift in the ROI, it could be far in the future, but it could be absolutely massive when you get there.
Yeah.
So thinking of it more as the way that, pharma companies, what they make off a drug when it actually comes to fruition.
Absolutely fascinating stuff, Amanda.
Yeah.
Thank you very much for joining us.
Yeah.
And please join us now live on WeChat for our Q&A. Thank you very much for listening.
Bye-bye.
Thanks for watching. Now join us online and on social media with our experts so we can answer your questions directly and keep this conversation going.